So the second half of class here tonight is talking about solving equations. I'm not sure if any of you are taking micro or macroeconomics with me this semester or plan to take me in the winter or any other semester. But this is a chapter that we typically, not we, because this is my first time teaching this class, but this is a chapter that's typically skipped by the curriculum. And part of that's because economics wasn't part of the business curriculum until last year. And so we're trying to slowly incorporate economics into the general business core. And so one way of doing that is here in this business math course, we're adding some additional elements that would be helpful if you're going to take macro or microeconomics, particularly in terms of solving supply and demand. So this is kind of like a little introduction to algebra. Really, it's just determining how to solve equations when you have an unknown variable. So like if you just have a mathematical expression of like 5x equals 20, what is x? That's what solving an equation for an unknown is. Sometimes you have simultaneous equations where you have the unknown on both sides of the equation. So when we do supply and demand and principles of economics or macro microeconomics for supply and demand, you'll have a demand equation and a supply equation. You'll have your unknowns. And in order to set them equal to each other, or in order to find the unknown, you set the equations equal to each other, rearrange the unknown to one side, and figure it out. That's really what we're going to do here. And then the second part is solving word problems. It's kind of easy if you see the expression, but if you don't know how to set up a problem, that is one of the trickiest things that students run into when they have this. And I don't really necessarily I have word problems, a couple of them in economics. So this could be helpful it would be more helpful in microeconomics than macroeconomics, where we do some problems where we don't reach market equilibrium. So just for analogy, so when you see when I say expression, it just means that there's some combination of numbers and terms. So what's the difference between an expression and equation? Well, an equation basically has some sort of it has two mathematical expressions, and there's some equated value between the two of them, between one side and the other side. So think about like a scale, like that scale where we had the checkbook register and the bank statement, and we were reconciling and making it even weights. That's what an equation is. It's trying to like finesse the variables around and the numbers around so they're balanced, and you also know like what the missing values are. An expression is just like, okay, it's like 21 is a mathematical expression. 21x is a mathematical expression. But if 21x equals 105, then that's an equation. A formula is an equation that kind of expresses things in symbols or a general fact, rule, or principle. So if you were to take economics, we would learn some formulas. So one of the formulas is to calculate consumer surplus in microeconomics, where it's not really a equation. It's just a system of expressions that are representative of some numbers that you'll already have access to find the actual value that you're looking for. So like you need price, you need quantity, you need something else. So it's like a cookbook or a recipe for finding the answer to something. That's what a formula is. So like when you get a formula sheet that has a bunch of expressions on it to solve things, that's what a formula is. And then variables are basically your unknown values. They're the terms in the mathematical expression. So if you have like 21x equals 105, this is an equation because the equal sign. This is a mathematical expression. This is a mathematical expression. This is a variable. And then constants are just things that don't change. So this 21 is a constant. The reason why is it's a scalar that scales up x by 21 times whatever x is. And then 105 is a constant because it's just a number. So a variable is these like letters. Constants are either scalars, coefficients, numbers. Formulas are things that help you solve equations. Equations have an equality. Expressions are just mathematical combinations. So most of you probably are comfortable with this, but just as a reminder, and if you aren't comfortable with it, then it's important that we go over this. If you just see like the letter B, B represents something. Maybe B is equal to 5. Okay. Well, if B is equal to 5, then that means that B is 5. It's not 10, it's not 20, it's not 100. Whenever you just have a letter by itself, then just assume that the coefficient is 1, meaning a coefficient is a number that is some number that's here. So not hashtag B, but no, some number here that scales it up. It's called a scalar. So like if you had 4 in front of B and you knew B was 5, then 4B would be 20. Because you have to multiply 4 times whatever the value of B is. So 4 times 5 is 20. So whenever you have a variable by itself, then just assume that it's just 1 times whatever that value is. If there's no letter or no sign in front of it, then just assume it's positive. So C could be negative. So let me be clear there. C could be negative. C could be -1, but you don't put negative C because basically that's saying -1 times -1, which is +1, which is incorrect. But generally speaking, if there's nothing behind on the left-hand side of this C right here, it's not 0. I'm just trying to highlight it. Then it's a positive number. So if you have 4 by itself, it's +4, which most of you are aware of that. But just to be clear, if it's 4, it's +4. If it's C, it's +C. Even though the variable value may be negative, that positive sign implies that you're multiplying +1 times the negative number, so it stays a negative number. So if C was -2, but you put a negative sign being like, well, it's -2, so it's -C and C is 2. No, C is -2, and the positive sign keeps it that way. The negative sign would make it +2. So you want to make sure that you're not flipping things on accident. So again, I didn't plan this, but here it is, the scales of justice, as I showed before with like the balance of the checkbook and stuff. Equations need equality. And so this is the mathematical equation that is expressed from this word, this statement or this word problem. Ralph's age in 8 years will be 58. The variable A represents Ralph's age. So that means that we want to figure out what Ralph's age is. Well, if Ralph's age in 8 years is 58, that means that on one side we have 58. And this needs to be equal so they're not out of balance. And we know in 8 years he'll be 58. So A represents what Ralph's actual age is. So if we want to solve for A, our equation is A plus 8 equals 58. So how do we solve this? Well, you need to isolate the unknown variable. By isolating the unknown variable, temporarily, we may have imbalance in the scales, but at the end, we should have balance in the scales. So how do you get A by itself? Well, you need to get this -8 out of here. Well, so you get rid of the -8, and then you're left with A. But in order for this to stay balanced, you need to subtract 8 from the other side as well. And when you do that, you're left with 50. So the answer to how old is Ralph is 50 years old right now because we solved for A. Any questions about that? So again, as I mentioned before, if you do something on one side, so if you like multiply by 5 here, you need to multiply by 5 here. If you subtract 3 here, you need to subtract 3 here. If you add 2b to this side, you need to add 2b to this side. There needs to be equality maintained. So when I said there was a temporary imbalance, it means that like, okay, you multiplied by 5 on this side, but in order to get it back to balance, you have to multiply by 5 on the other side. And okay, over here you subtracted by 3, but you also have to subtract by 3 to get it back in balance. So again, all of these orders of operations, adding, subtracting, multiplying, dividing. So you could also divide by 7 and it would be on both sides. So whenever you're solving an equation, each side and each thing has to be done on each side. So I don't call this the opposite process rule. In fact, I didn't even know it had a name. But I guess what this means, I guess Ralph is now Dick because it says Dick's age Dick is age A plus 8 and it equals 58. So I guess there's some inconsistency here, or maybe I changed it to Ralph. I think I did change it to Ralph. So this is Ralph. So what the opposite process rule says that if an equation is doing addition, you need to do subtraction. And if a problem is doing multiplication, you need to do division. And if a problem is doing subtraction, you do addition. So the reason why you need to do that is so you can isolate the unknown variable by itself. So if A plus 8 equals 58, well, we need to add something to 8 to get 58. But in order for us to be able to find the answer, we need to subtract 8 from both sides so we get A by itself. So we're going to add, we subtract. When we were going to multiply, we divide. When we were going to divide, we multiply. When we were going to subtract, we add. We just do the opposite. We've already solved this like 4 times. So let's move on, unless anyone wants a question. So like if this said A minus 8 equals 50, we would need to add 8. Whoops. We would need to, let me move this over. Okay, so if we have A minus 8 equals 50, then we need to add 8 to both sides to get A by itself. And then we end up with A being 58. So that's the opposite process, is that if you're subtracting, you add. If you're adding, you're subtracting. And same is true for multiplication and division. So when it comes to equation equality, you can do these operations to both sides. So in a way, this is kind of just the opposite process rule. But what it's saying is that you can add scalars as long as you're consistent across this. So like if we wanted to make 7G 14G, we could turn 35 into 70 because we multiplied by 2 on both sides. So what this is really saying is that you can scale up, scale down, do whatever you want with this as long as you're consistent with both sides. It won't change the ultimate answer. So if you like 14 to 70 divided by 14 instead of 35 divided by 7, you can multiply by 2. It's not really necessary. It's not really that useful. But, and then also going back to the opposite process rule, 7G implies multiplication. Because remember, this is a scalar. So this means you're multiplying G times 7, or 7 times G. It's not the new phone service, it's just 7 times G equals 35. So if you want to get G by itself, well, you're multiplying, you got to divide based on the opposite process rule. So you end up with divide by 7, divide by 7. So you get G equals 5. So dividing both sides by 7 doesn't change the equality. Multiplying both sides by 7 doesn't change the equality, it just takes you further away from the actual answer. So if you multiplied this by 2 on both sides, you'd have to divide it by 2 again just to get to where you need to go. So it's kind of unnecessary. So we feel good so far about this. Okay. If you have any questions, just let me know. So in this case, we have multiple steps, which inevitably you're going to have in any sort of equation that is more than just like a scalar, or like x plus 2 equals 5. So in this one, you have multiple steps, multiple processes. So again, through the opposite process rule, you know that we have addition, so you're going to have to subtract at some point, and you have division, so you're going to have to multiply at some point. So we have h over 4 plus 2 equals 5. Now, the first thing you should do when you have these problems is you should do the addition and subtraction first, and then do the multiplication and division after. So I know order of operations, when you solve a problem with everything known, that you go like parentheses, exponents, multiply slash divide, and add, subtract. But in this case, we don't have PEMDAS problems. If we did with parentheticals, then it's different, and you could do scaling through if there's a coefficient on outside the parenthetical. So like if you had like 2x plus 1, you could do 2x plus 2 and then solve it to make it simplified. But in this case, what you're going to do is you're going to subtract first, because you're doing the opposite process of adding. So what you want to do is you want to add or subtract first, and then you want to multiply and divide. The reason why you do that is it's easier to isolate the unknown variable by itself when all of the numbers of addition and subtraction are on the other side of the equation. And multiplying and dividing allows for it's basically a fraction. So like here, h over 4, if you multiply by 4, it's 4 over 4 times h. The 4's cancel, you're left with 1, so you're isolating h because you're trying to find what h is. So if you're thinking about it like a fraction, that's why multiplication and division is easier, because remember, it was easier to multiply and divide fractions than to add fractions. So the same process is true here. So in this process, you're going to subtract both sides by 2 for equality purposes. You're left with h over 4 equals 3. Well, in order to finish this off, we need h by itself. So this is 1/4 h. So to get 4/4 h, or 1h, you multiply times 4. So 4 times 3 is 12. So h is equal to 12. So again, you added 2 or subtracted 2 from both sides. You got 3. H over 4 is really 1/4 times h. So you multiply times 4 to make it 1h, and then got to multiply the other side for equality purposes. You get 3 times 4, you get 12. Any questions? Any need for me to go over this or clarification? If I'm going too fast, it's okay. If you feel good about it, great. But if you don't feel good about this, or you feel like I'm going too fast, or it's overwhelming because there was 2 steps to this one, that's okay. As I mentioned, just as I mentioned before, if you have parentheticals, that's the only time in which you would probably do some multiplication first. what we were talking about here with multiplication was that you're multiplying the unknown. Here, if you have a parenthetical, like I said, if you have 2 times x plus 1, then you have 2x plus 2, because you're multiplying, you have to multiply through the entire equation. So it's not just 2x plus 1. If something's in a parenthesis, each term gets multiplied by this coefficient or scalar that's outside the parenthetical. So 2x plus 1, 2 times x plus 1 is 2x, because 2 times x plus 2 times 1, which is 2. So it's 2x plus 2 is the actual expression. Once that's done, then you just go and solve it like the other equations that we just did. So the parentheses rule says, okay, I'm going to scale this through, and then I'm going to go to work with trying to find what x is now. Sometimes it may be that this cancels out. So maybe if you get like 2 times x plus 1 divided by like 2, these 2's cancel out, and then it's just x plus 1. So if there's some sort of cancellation that can happen, you could do that kind of from a fractional perspective. Like, okay, if I have 2 over 2, that's really 1, so I don't even need this anymore. It's just whatever it was before. But if you don't have that, then you should just factor it through. This is called factoring, when you multiply a scalar through it. Or it could be you're multiplying times 2 expressions, which gets more complicated. We're not doing polynomials here, I don't think, so I wouldn't worry about that. So in this case, because we have the scalar outside of the parenthetical, the first step is we need to factor that through. So 5 times p is 5p, 5 times 4 is 20. But remember, this is a negative sign, so it's really subtracting 20, not positive 20. And then in order to solve this equation, again, we have 2 steps. We do the multiplication we do the multiplication or division second. We do the addition subtraction first. So we add 20 to both sides for equality purposes. So 20, this cancels out. 20 plus 20 equals 40. So we now have 5p equals 40. In order to get p by itself, we divide by 5, because then it turns it into a fraction that's 1. Or this by 5, p is equal to 8. Any questions about that? Okay. Now, what if we have unknowns that are of the same variable? So if we have a bunch of a's, we got 4a, and then we add another a, how do we combine that? Well, it's kind of like a common denominator with fractions, where if the unit is the same, if you have the same kind of identifier, then the values will be can be combined. So if you have 4a, that's basically 4 of a, and then a by itself is 1a. So if you do that, you add basically the scalars together. So you get 4a plus 1a, which is 4 plus 1 times a, and you get 5a. So for this step, if 4a plus a equals 20, well, this is 1a, so you end up with 4a plus 5a is, or 1a is 5a, equals 20, divided by 5 with both sides, a is equal to 4. Oops. So again, it's like a common denominator where if you have the same term, you have like terms, you say combine like terms. A is the same as a, so 4a plus a equals 5a, and then 20 divided by 5a should be 20 equals 5a, a equals 4, because we're dividing both sides by 5. So always combine those unknowns together. Now, how do we solve word problems? Hopefully all these expressions feel comfortable. But when we're trying to solve word problems, we have to think about things closely. Now, when I was in law school, one of the tricks that we learned in law school was always read what's known as the call to question. And so whatever sentence within the paragraph has a question mark at the end, read that first. Because once you read that, that should tell you what you're looking for. And then you can go through the facts and all the different numbers and all the red herrings to figure out, okay, what do I need to pull out of here? So this says to read the entire problem carefully and read it again. I would say if it has a question mark and it's asking for what you want, write that down first, then go through the facts and figure out, okay, well, they want this information, this is part of that, this is part of that, this isn't part of that, this is part of that, and then I can go to work. If the call to question doesn't make sense to you, then you have to figure out, okay, what do they want? What are they looking for? And is there a creative way to figure this out? There's a chance that you may have more than one unknown value. But if possible, sometimes it isn't, but in our case, it will be. If it's not entirely, if you have more than one unknown you need to find, typically you can express that other variable as the same variable. So let's say that like Bob makes 6 times Tim. Bob and Tim make 10,000. How much does Bob make and how much does Tim make? Well, those are two unknowns. We don't know how much Bob makes. We don't know how much Tim makes. We know how much they make combined. We know the relationship between Bob and Tim. So if Bob makes 6 times Tim, that means that Bob's salary is going to be 6x. Say X, let's just say X is Tim's salary. So we know Bob's is going to be 6 times whatever Tim's salary is. And then Tim's salary is just going to be Tim's salary. So that's X. And that equals 10,000. Since they're both expressed in X, we know that 7X, we can combine these. We get 7X is equal to 10,000. When you divide that by 7, you don't get a perfect answer. Get about 1428.57. So we know that's Tim's salary. And then we know Bob's is 6 times Tim's. So then we just multiply this times 6, and we get 8571.43. So this is Bob's, this is Tim's. So if you have multiple unknowns, the goal is to just combine them into one variable. So that's what step 3 is. And then visualizing the relationship is basically converting it from words into some sort of equation to solve, which is what I just did. So step 1 was, this is what it's asking me. It wants me to know what Bob makes, what Tim makes. We wanted it to be expressed in terms of one variable. So X is Tim's salary. It could have been Bob was X and then Tim was 1/6 X. It could have been either way. Both would have given you the same answer. Just would have been a messier problem because it would have been 7/6 X equals Bob's salary, 10,000 or 6/7, I'm sorry, equals 10,000. But nonetheless, we got to the right answer. And then again, check your results to make sure you feel like you got the right answer. Another aid that the book recommends is making this 3-columned phrase or this 3-column table where basically the question, whatever the question is what this column has. So if it was like the Bob and Tim salary, the unknown would be Tim's salary and Bob's salary. And then we would create a variable. We created X. X represented Tim's salary. Tim's salary. And then Bob's salary is 6 times Tim's. So if we know that Bob's salary is 6 times Tim's, then we can do 6x, because it's a scalar and it's combined, plus x equals whatever it was, 10,000. And then we know 7x is 10,000. And since we've defined x as Tim's salary, when we divide this by 7, we get Tim's salary. Since we've defined Bob's salary 6 times Tim's, then it's just 6 times whatever that is. So this is what you're trying to find out. This is the expression you're using for the unknown. And this is the relationship between the unknown and what you're trying to figure out. So that way you can kind of organize the problem and then create an equation from that. And hopefully easier to read than what I just wrote on here. So here's an example problem that we can work through. ICM sold 4 times as many computers as Ring. The difference in their sales is 27. How many computers of each company were sold? So what we're trying to figure out is how many computers of each company were sold. That's why I said go to the call to question. Well, we know there's Ring and we know there's ICM. So our unknowns are ICM and Ring computers. The variable that we're going to use is X. But what is X going to represent? Well, since ICM sold 4 times as many computers as Ring, we should express X as Ring computers sold, because it's the smaller value. You always want X to be smaller if you're scaling. It's easier to scale up than to do fractions. This is your variable. This is your unknown. And then your relationship is that ICM is 4x Ring. And we also know that 4x minus x, or we know that Ring minus ICM, excuse me, ICM minus Ring equals 27. So how do we combine this into an equation? Well, we know the total number of computers is going to be, we know that Ring is going to be X. We know that ICM is going to be 4 times that, 4x. But instead of combining this into being 5x equals some number, we don't know the total number. We know the difference. So what this is telling you is that ICM, which is 4x, minus Ring, which is x, equals 27. That's the equation that you need to solve. So when you solve that problem, you can combine like terms. You get 4x minus x is 3x equals 27 divided by 3. X equals 9. So what is x? X is Ring's computers. So we know that Ring sold 9. And we know that ICM sold 4 times. So 4 times 9 is 36. We also know they sold 27 more. So 27 plus 9 is 36. And there's your answers. I guess they use C instead of X. But they got the same equation we did. 4x minus x equals 27, or 4c minus c equals 27. And then I guess I'll erase my work so you can see this. So 4 minus c, get 3c, c equals 9. That's Ring's computers, which are 9. 4 times 9 is 36, or you could have done 9 plus 27, which is 36. So that's how you solve a word problem. You got to figure out what you're trying to find, which is ICM and Ring's computers. You express the variable in usually the smaller value if you have multiple unknowns. And then you have to look at the relationships. So this wasn't a total number of sales one, this was a difference in sales one. So you have a subtraction problem instead of a addition problem. Any questions about how I solved this problem? Any concerns, questions, etc.? Okay, let's do another one. So this already has the work done, but basically Andy sold watches for $9 and alarm clocks for $5 at a flea market. Total sales from 35 watches and alarm clocks were $287. How many of each did Andy sell? What were the total dollar sales of each? So this one is a little more involved because instead of it just being like we sold this many watches more than alarm clocks. We know that the total number of items sold is 35. And that's one of the questions is how many items, how many watches did Andy sell? How many clocks did Andy sell? Well, if we know we sold 35 of them, we have to denote one of them as the value of choice. So we could choose C for clocks. We could choose W for watches. They use W for watches, so we'll go with W for watches. So we know W stands for watches sold. Now, we know 35 were sold in total. So instead of just trying to make a second variable of like C for clocks, we know that the number of clocks sold is 35 minus W. So we now have two variables. We have additional information. We know that each clock sold for $9, and we know that each watch sold for $9, and each clock sold for $5. We also know the total number of sales was 287. So how do we put all of this together? Well, the final answer, what we're trying to figure out from dollars, W is going to tell us how many of each watch, how many watches were sold. But because we know the dollar value, if we multiply the dollar value times the number of watches sold, we'll actually get the total value of those. So when you're in economics, you learn about total revenue. Total revenue is price times quantity. So the quantity of watches is W, the price is 9. 9 times W is the total revenue sold from watches. So if we multiply that and create that as a scalar, we get 9W. We don't know, we don't have a C, but we know that it's a complementary thing because however many items weren't watches, they were alarm clocks. So we only have 2 to choose from. And we know we sold each one for 5. So if we add in 5 times 35 minus W, we get these two. This is the total revenue from clocks. This is the total revenue from watches. Add it together, you get 287. So we now have our equation. However, we can simplify this equation further because we have a parenthetical here, so we can scale or we can factor this through, and we end up with 9W. Oops, let me use a different color here. 9W plus 175 minus 5W equals 287. Now we have 2 items that have W's in them. We should combine those. So we end up with 9W minus 5W is 4W. 4W plus 175 equals 287. We then use the opposite practice rule. So if you're doing an addition problem, you subtract. So to get this by itself, we subtract both sides by 175. We end up with let's see here, 4W is equal to 112. Divide both sides by 4. W is equal to 28. So we know how many watches were sold by Andy. He sold 28. He sold 35 total items. So if we do 35 minus 28, just 35 minus W equals 7. So we know that we sold 7 clocks, 28 watches. If we want to determine the total amount of money they sold, we just multiply these numbers by the price. So we sold $35 because it's 7 times 5, $35 in clocks. 28 times 9 is 252, I believe. Yeah, 252. So this is a long problem because there were 2 things you had to figure out for each thing, but it all fit into one simple equation. So first step was to figure, okay, we need to parse watches and clocks. We'll express them in watches. We know that the total amount of sales in terms of units is 35. So the complement of watch sales is clock sales. So 35 minus W is clock sales. We know how much in total we made in revenue. We know how much each item sells for. We can put those as scalars on the outside to basically determine how much money of each was made that is relevant to 287. Plug that in, solve for W. You find out there's 28 watches sold, 35 minus W, 7. So there's 7 clocks sold. Multiply that times the original scalar, which is the price of the product, and you get the total revenue for each, which is $35 for clocks and $252 for watches. So does anybody have any questions with this problem? Ooh. It's a detailed problem. You have a couple of these on homework or chapter 5 homework, but one of them might be this complicated, but the rest of them should be a little more straightforward. Most of them are just mathematical equations. You don't have to derive them, but some of them you do have to figure it out from the info. So does anybody have any questions? I like how they didn't even finish the question. I had to finish the question. What were the total dollar COs of each? There's nothing in here that shows you the actual answer for that. So solve an equation. Again, use the method of subtraction. Minus 64, you end up with A equals 34. Then you can check it. 34 plus 68 is, or 64 is 98. Then you get the same answer. Y equals 75. And you don't have to do any addition. You just divide by 5. So 5y, you cancel this out. 75 over 5 is 15. And then you can plug it back and make sure the number is correct. So for this one, you have to factor through. So 4 times P is 4P, 4 times 9 is 36. So 4P minus 36 equals 64. Then through the, again, remember you do addition or subtraction first before multiplication or division. So add 36 to both sides. You get 100, so 4P is equal to 100. Divide by 4, P is equal to 25. And then you can check. Plug in the missing node. So 25 minus 9 is 16. 4 times 16 is 64. 64 and 64 are the same. Voila. So here's a word problem. We'll do one more word problem. Whoops. To make sure you're understanding it. So Jessica and Josh are selling entertainment books to raise money for the art room at their school. One book sells for $15. Jessica received the prize for selling the most books in the school. Good for her. Jessica sold 15 times more books than Josh. Good for her. Together they sold 256 books. How many did each of them sell? So the question is, how many books did each of them sell? Remember how I said go to the call to the question first and then go through and read? The reason why I do this is because this information is irrelevant. It doesn't matter how much you sold the book for, because it doesn't say how much in total sales they sold. It only says how many books they sold. So yeah, if the problem asked what the revenue was, you'd bring in the 15, but by knowing that the call to question is saying how many books they sold, you can just cross this out. This sentence is irrelevant. So instead of trying to shoehorn 15 in, you don't really need it. So we know Jessica received the prize for selling the most books in the school. Good for her, but not relevant to the problem because it's not giving us a specific value to calculate. What matters is this sentence right here. The entire problem is this sentence. This doesn't matter, this doesn't matter, this doesn't matter. None of this matters except for this and the actual question. I mean, it's good that we know that Josh and Jessica exist, but it doesn't affect the answer. Jessica sold 15 more books than Josh. They sold 256 together. So our unknowns are going to be how many books Josh sold and how many books Jess sold. If Jessica sold 15 times more books, then we can treat X as the books that Josh sold. And then 15X is going to be how many Jess sold. And we know that the relationship between these is that 15X is Jess and that the sum is 256. So what kind of equation do we get from this? We get 15X is Jess's books, X is Josh's books, equals 256, which means that if you add like terms together, 16X is your sum, is equal to 256. Divide both sides by 16 to get X by itself. And then you end up getting X is equal to 16, because it's 16 squared is 256. And then if you want to find so this is Josh. If you want to find Jessica's, you multiply times 15, which is 240. So this is Jess. So notice how in word problems, it's important to look at the call to question first, because then you might have spent 10 minutes trying to figure out where the $15 fits. It doesn't fit anywhere because it doesn't need to be there. It was literally just this part right here. 15x plus x equals 256. Added together, 16x equals 256. Divide by 16. X is 16. That's Josh's. And then Jess is 16 times 15, which is 240. So that is a word problem. Any questions? Okay, so one last thing that I want to share before we adjourn for tonight is the practice Excel sheet, the Excel assignment. So I will share my screen one last time. So this is the Excel spreadsheet that you'll be filling out for the Excel assignment. There are two parts to this. The first part is kind of like a sort of reconciliation, but not exactly like a reconciliation, but you want to do a real-time accounting of your assets and your liabilities. So some of these you may have, some of these you may not. So your checking account, your savings account, investments, retirement, cryptocurrency, you may have some, all, or none. To answer your question, the spreadsheet is a replacement for the quiz. There is still a homework assignment, but the quiz, well, there won't be a quiz because of the spreadsheet. So what I've done is I've done a couple Excel formulas in here. So like this will do a running total of your assets, will do a running total of your liabilities, and this will subtract your liabilities from your assets for a net value. So let's say you have $1,000 in your checking account, and you got 500 in your savings, and you got $700 in credit card debt, and you have a rent payment of $700, and that's all you got. Well, then this added up your assets, which is $1,500. This added up your liabilities, which is $1,400, and then the net difference is $100. So all you got to do is plug in the numbers that are relevant, and then this will do the calculation for you about net and assets and liabilities. The other part is to do a monthly accounting of kind of your budget. So all of these, you may have some of these, you may have none of these, you may have a few of these, and there might be things that you want to include. If there's something that you want to include and you have all of these expenses and income, then what you do is you right click and you put insert, and it'll give you a new column. So you could put like, I don't know, cookie bunny. Maybe you have a cookie budget. So your cookie budget, you'd put that in month to month of how much you're going to spend on cookies. If you find one of these that is irrelevant, then you could click on cookie money and delete it. And then sometimes if it says delete the entire column or delete and it wants to give you an option, say delete entire column. But if you use the top part, I think it just deletes it without prompting you. So what you'll do is you'll put your income, monthly income here, and this goes out to December 2022. Here you'll put your taxes, which in the assignment I said, basically just estimate 25% for your taxes, because 20% for FICA and federal taxes, 4.25% is the Michigan state income tax. So that kind of gives you a round number. So if you have education expenses month to month, maybe you're paying every month, or maybe you're paying a big lump sum in January and a big lump sum in August, you can put that in. Housing, if you have monthly rent or mortgage, health insurance, car insurance, you can add those up. If you have a car loan or car payment, utility payments, internet payments, phone payments, subscription services, food, travel, any existing debt that you're going to pay off, and entertainment. And then once you've plugged all this in, it'll tell you how much money you have left over. So like, let's say I make $2,000 a month, my taxes are $500, I paid $100 in tuition, my housing's $800 a month, I pay $200 on insurance, I've got $50 in utilities, $100 in phone, $20 in internet, maybe I got Spotify, I spend $300 on food, and then I spend $100 on entertainment. Oh no, I'm bringing in $180 less than I need for my baseline expenses. So does that mean maybe my taxes are lower than that? So if I have a more accurate accounting of taxes, maybe they're 320. Oh, look at that. I'm doing just okay. And you can do this out and forecast this out. So maybe there's concerts, movies, events, travel, education bills, changes in housing, your car gets paid off, changes in job, increases in income. You can account for that all the way to December, and then you can kind of see how much money you have left over month to month, and then at the end, the total. And then you can use it as a personal finance, use it as a budgeting Excel spreadsheet for your own personal finances to figure, okay, well, there's all this, I'm 3,000 in the hole, so how am I going to make that 3,000 up? Am I going to work more hours? Am I going to find a second job? Am I going to pay it off? Am I going to get a scholarship, et cetera, et cetera? So this has a dual purpose. One is to kind of be adjacent to the banking lecture, but also giving you an excuse and a template to kind of fill things out so you can start forecasting ahead and figuring out if there's any sort of budget changes or plan changes that you need to make. And so that is due a week from Friday. The homework for chapter 4 is due on the 22nd. Chapter 5 homework is due on the 29th. I will send an announcement at the end of the week this week that to let you know what we're covering next week. We may do a review for the first exam next week, or we may go on to chapter 6 and 7 material and then have the review the following week when after you've submitted the homework for chapter 5 and done the chapter 5 quiz. We could review, and then the test will be a week or two later than we anticipated, but we'll still be on time and on pace with the material, even though we missed the class on the 8th. So does anybody have any questions?